Good morning. I am Sharina VB, Assistant Professor, MAS College, Marambali. I am going to discuss about line drawing algorithms. Line drawing algorithms in computer graphics can be done by calculating intermediate positions along the line path between two specified endpoints. That is, we are given two endpoints of a line and we are using the slope-intercept equation for a line. That is, y is equal to mx plus b. Let me take it as equation number 1, where m is the slope of the line and b is the y-intercept of a line. The two endpoints of a line segment are given in the figure, that is x1, y1 and x2, y2. So in this figure, we can see the two endpoints x1, y1 and x2, y2 given by p1 and p2. We can determine the value for slope m and b-intercept as given in equation numbers 2 and 3. That is, the slope is calculated using y2 minus y1 by x2 minus x1 and b can be calculated using the equation y1 minus mx1 that we are taking from equation number 1. Thus, for a given x interval delta x along a line, we can compute the corresponding y interval delta y as delta y is equal to m into delta x. Similarly, we can obtain x interval delta x by delta y. That is, delta x is equal to delta y by m. We can take it as equation numbers 4 and 5. Now, using the slope value, that is, the absolute value of slope is less than 1, that is, for every integer value of x between x1 and x2, we can calculate the corresponding delta y as delta y is equal to m into delta x. And in the case of slope is greater than 1, for every integer value of y is between y1 and y2, calculate the corresponding value of x as delta x is equal to delta y by m. In the case of slope value is equal to 1, delta x is equal to delta y. In each case, a smooth line with slope m is generated between the specific endpoints. Now we can see the DDA algorithm. The full form of DDA algorithm is Digital Differential Analyzer. It is a scan conversion algorithm based on calculating either delta y or delta x that we have seen in equation numbers 4 and 5. Now we sample the line at unit intervals. It is incrementing the line using 1. And m can be any real number between 0 and 1. The calculated y values must be rounded to the nearest integers. Now we can convert it into different cases. DD algorithm case 1. In this case, first a line with positive slope. If the slope is less than or equal to 1, we sample at unit x intervals. That is, delta x is taken as 1. And the corresponding y value is calculated as yk plus 1 is equal to previous y value plus m. That is equation number 6. Here, k takes the integer values starting from 1 for the first point and increases by 1 until the final endpoint is reached. Then case 2. For lines with positive slope greater than 1, we are reversing the roles of x and y. That is, we are taking y at unit intervals, delta y is equal to 1 and calculate each succeeding x value as xk plus 1 is equal to xk plus 1 by m. Put it as equation number 7. Equations 6 and 7 are calculated on the assumption that lines are processed from left endpoint to right endpoint. Now case 3. If this processing is reversed, that is, case 1 is reversed, that is, starting endpoint is at the right, we have delta x is equal to minus 1. In that case, next y value can be calculated as previous y value minus m. That is equation number 8. Now case 4 is the reverse of case 2. That is, slope is greater than 1. We have delta y is equal to minus 1 and the next x value is calculated by previous x value minus 1 by m. Put it as equation number 9. Equations 6 through 9 can be used to calculate pixel positions along a line with negative slope also. If the absolute value of slope is less than 1 and the start end point is at the left, we can set delta x is equal to 1 and calculate y values with equation 6. If the start end point is at the right, for the same slope, we set delta x is equal to minus 1 and obtain y positions from equation number 8. This is the summary of DDA algorithm. In step 1, we are starting the algorithm. Step 2, we are declaring some variables x1, y1, that is the first endpoint, x2, y2 is the second endpoint, dx, dy, x, y and step are the integer variables. In step 3, enter the values of endpoints, that is x1, y1 and x2, y2. In step 4, calculate dx is equal to x2 minus x1. In step 5, calculate dy is equal to y2 minus y1. In step 6, we are checking the condition. If absolute value of dx is greater than absolute value of dy, then step is equal to absolute value of dx. Else, steps is equal to absolute value of dy. Now, in step 7, we are incrementing with the help of the previously calculated step values. That is, x increment is equal to dx by step and y increment is equal to dy by step. So, assign x is equal to x1, assign y is equal to y1. That is the starting point. Now, plot the starting points. Set pixel of x, y, comma, intensity value. Intensity value depends upon the hardware. Now step 9 is for k is equal to 0, k less than steps, k plus plus. That is, we are calculating all the intermediate pixels using the increment value calculated in step 7. That is, x is equal to x plus x increment, y is equal to y plus y increment. And set pixel of round of x, round of y, comma, intensity. Now, in this step 9, we are calculating all the intermediate pixels and that is the end of the algorithm. So, step 11 is end algorithm. So, this is the short summary of DDA line drawing algorithm.